This is my first time in Israel. I'm super happy to be here. I'm visiting from Toronto. And the title of my presentation today is We'll Do It Live, Testing Your Software in Production. So I work for a company called PagerDuty. How many people here have heard of PagerDuty? Okay, so there's a few, I saw a few people didn't put up their hands, so I'll give a brief description. We call ourselves an incident management platform, and what that means is, you have your monitoring tools that help you to detect problems, and you have people at your company that are there to, that can fix the problems. And what we do is we connect the information from the monitoring tools to the right people. So we provide the right problem with the right context to the right people, to the right person. So about me, I am a software engineer at PagerDuty. I've worked there for three and a half years. I've worked on a variety of projects at PagerDuty in my time there, from user-facing features to back-end services, and I'm currently a member of the core team. And what we do is we build services and libraries that help empower the rest of the engineering division at PagerDuty. So I'd like to begin my talk with a quote, and the quote goes as follows: "People who don't take risks generally make 2 big mistakes a year. People who do take risks generally make about 2 big mistakes a year." My talk today is sort of related to the topic of risk, and I'm going to bring up the word risk a few times. And this quote kind of highlights the misperceptions that people have when it comes to the topic of risk. So when we think about risk as it pertains to software, we think of testing as a tool that can help us to mitigate risk, right? It helps reduce the risk inherent in software development process. We also have to keep in mind another risk in the software development process, and that's the risk of moving too slowly. So I'd like to frame the problem, the challenge that we have when we're testing software. We kind of have a few things that we're trying to optimize. We're trying to optimize the user's experience. So I test software because I don't want a user to see, a bug that I've introduced with my code. I try to minimize operational pain when I'm testing software. I want to make sure that if I've introduced a non-performant query, for example, someone else is not going to get woken up in the middle of the night as a result of the problem. While I'm trying to optimize for both of these variables, I have to deal with a constraint. The constraint is that developer time is a finite resource. So it's really about how do we make the most efficient use of this constraint, of this finite resource. So to talk about testing, let me begin with maybe a conventional approach to testing with a web application. This is basically how the testing environment at PagerDuty looked when I joined, and it continued to look for a long time. So if I'm making a change, if I'm a developer and I make a software change, I'm going to first validate that it looks good on my local box. I'll run it in a development environment. Assuming everything looks good, I'll deploy it to staging. A staging environment is something that is sort of production-like, but not really full-fledged. It's kind of like production light. Next, if everything looks good, maybe I'll want to validate that it behaves well under load. And to do that, I'll promote it to the load test environment. Assuming it looks both correct and performant, I'll deploy it to production. So this is actually, it has a lot of benefits, but what's the problem? So I'd like to talk first about the problems with staging, the staging environment. So if I'm using a staging environment, this works really well at a company with 5 people. You have one staging environment. When a developer wants to make some changes, they, say, declare in some way that they're using staging. We use a locking system. And they deploy their changes to staging, do their testing, and then release the lock. So the problem comes in when you go from 5 developers to 50 developers, and they're all trying to use the same environment. What's more, maybe your service has evolved. Maybe it used to be a single application, and now you've scaled it out to, multiple microservices that interact. If I'm developer A and I'm testing a certain service, and developer B is testing another service in staging, can either of us really be sure of the correctness of our results if we're both testing at the same time? You often run into cases where, I can't validate that my changes are correct because the service that B was testing is broken. And more generally, staging can often be broken. Like, who owns staging? If a production service is down, someone is going to get paged. If a service in staging is down, generally no one gets paged. And you kind of have this problem of staging falling into disrepair. Pardon me. So the result of all of this is that if I'm a developer and I want to test a change to source code, or like I want to test a change that I've made to a service, I often might have to spend a few hours debugging what's wrong with staging. So the ROI here is kind of out of whack. I've wasted a bunch of time just getting my test to run. Okay, now I'd like to talk about some of the challenges with the load test environment. So there's a lot of advantages to doing load testing. The problem is, how do you maintain this? So what are the characteristics that we want in a load test environment? We want a realistic data set in the data store. We want a realistic fleet size. So, in some cases this might mean one-to-one with production. So if I have, 10 production servers, I might want 10 in load test as well. And then I want to somehow simulate realistic production traffic, and possibly also spiky, bursty traffic to simulate surges in traffic. So what are the challenges here? Maintaining the data set in parity with production can involve introducing a process to replicate the production data set from production to load test. And this is like another moving part. This is something that someone has to maintain. This is, something that can break. This is something that actually can be quite involved if you have to remove personally identifiable information from the data set. What about scaling your fleet to match production? This may not be hard, but it's certainly expensive. If you're paying Amazon $1 for every, if you're paying Amazon $1 for production, you've got to pay them another $1 for your load test environment. So at PagerDuty, for a long time, we had one-to-one parity between production and load test. We just found that it was cost prohibitive after a while. It no longer made sense. And then in terms of generating production-like traffic, if you think of all of the sources of traffic that your application has to deal with, whether it's coming from users of your API, users of your mobile app, cron jobs that run in the background, you can write kind of simplistic scripts that simulate production traffic, but in the end, how real can they really be? So I'd like to talk about, in contrast with the kind of conventional approach to testing web apps, some less conventional approaches. And some of these have gained more widespread popularity in recent years. So one idea is using local containers. Another idea is using disposable environments. And finally, the idea of testing changes in production. Now, these aren't mutually exclusive, and in fact, they're complementary. And you can use this kind of set of approaches to replace kind of existing conventional approaches. So by local containers, what do I mean? I mean that if I'm testing service A and has dependencies B, C, and D, maybe I'll spin up containers for each of A, B, C, and D on my local machine. This has a lot of advantages. First of all, no more contention problems. Every developer can test their changes on their local box. Theoretically, you may have scaling issues here. If your service depends on 1,000 other services or something like that, you may not be able to run them all in your local box. But generally, it's a pretty, big improvement. Disposable environments. What do I mean here? I mean that if I want to test a change, I press a button, and I get a copy of production that I can test my change on. When I'm done with testing my change, I just throw away the environment. So what this implies is that I've codified what my environment looks like. So I have, you can use tools like Chef or Puppet to describe your infrastructure with code. There's other tools that you can use to describe your entire environment. This is not necessarily as straightforward as it might seem, though. There's obviously a lot of moving parts here, but it's another promising approach. Finally, the idea of testing your changes in production. So why would you want to do this? Basically, the benefit here is that you know that the testing that you're doing has a realistic workload and a realistic environment. You're going to be able to catch changes that you wouldn't be able to catch in any other pre-production type testing. By doing so, you can really help your team to move faster and improve your ability to iterate. But what you really have to be aware of is that you need risk mitigation strategies here. And I'd like to talk about those. So risk mitigation strategies. So what I want to deal with here is the case of I've deployed something that's broken something. It's like a bad deploy. What do I want to make sure of? I want to make sure of, number one, that someone knows almost immediately that something has gone wrong. I want to make sure that the blast radius, the impact on users, is contained. So we know, the scale of possible affected users, and we want to make sure that it's very easy to roll back. So how do you know quickly that something has gone wrong? Here you want to leverage monitoring tools. So the previous speaker actually talked about monitoring and the benefits that it provides. What you can do is you can configure monitoring tools to alert you when certain metrics that you're emitting exceed thresholds. You want to leverage log aggregators. Why are those useful? Well, you can set up real-time searches. If I see more error messages than I'm used to in my logs over the last minute, let's say, that's a good clue that something's gone wrong. And those two inputs from monitoring tools and log aggregators can be fed into an alerting service. Alerting service, can be used to make sure that the team responsible for the software is aware right away. So that covers some good ground, but it's not actually sufficient. One other thing that you need to think about is breaking functional behavior. Even if you're not necessarily, your metrics aren't bad, or you're not seeing a lot of errors in your logs, functionally your product might not be the same. So one thing that we invested in at PagerDuty is end-to-end production functional testing. What this means is, what we did is we went through and we described these are all the behaviors that we think our product has, or should always be true of our product. And what we did is we codified all of those expected behaviors in tests, in a test suite. And we have a system that basically runs that test suite continuously against our production environment. So we basically treat our product as a black box, and we're executing tests against it. The moment that an expected behavior ceases to be true, someone gets alerted. And we affectionately call this system Watchdog. Okay, so once we're more confident that we'll know when something breaks, we want to make sure that we limit the blast radius of any breakage. So how do we do that? One popular technique is this idea of Canary Deploys. So Canary Deploys, I think the term comes from canary in the coal mine. So if I have 10 servers in my production environment, maybe I only deploy to 1 out of 10, thereby knowing that I've only broken only 10% of incoming traffic is affected by the break. In this diagram, I've indicated that the changed software is V+, and the original version is V. And of course, the canaries can be rolled back if if there's a problem that's encountered. Another strategy that you can use to limit the blast radius of any problems is via feature flags. So in this case, the idea is rather than deploying to a subset of hosts, deploy the change to all hosts, but basically the code doesn't get executed unless a feature flag is true for that user. So at PagerDuty, we use this idea to break down, to expose three different groups of users to software changes. The first group is internal users. So any new feature that we add to our product, the first set of users that see it is internal users. The next set of users would be like participants in our beta group. So people, any customers that are interested in getting features as soon as possible. And then lastly, if things look good for those two groups, we'll turn on the feature flag for our general user base. Okay, so rolling back. So this is, I've made a change, it's broken something. How do I, back out? The key here is boring. I want boring deploys. I want boring rollbacks. I want them automated if possible. I want them to be completely uneventful and completely predictable. I don't want to have to remember syntax or anything like that. So this is kind of a diagram that exemplifies the, sort of the deployment pipeline that we use at PagerDuty. We have an automated system that does the Canary deploy, observes if certain metrics look healthy, and then either rolls back or does the full deploy. But it doesn't really matter what your deployment and rollback tools look like, as long as they are boring. That's the key. Okay, so now we've talked about risk mitigation with the testing and production strategy. Now let's talk about like cultural kind of issues. So the cultural ingredients that you might want to consider. So one important thing, if you're considering like doing this type of strategy, is it's very fundamental to have a DevOps mentality. Meaning you build it, you run it. That's the quote that Werner Vogels, I think, originally used. And basic idea is, I've written software. I'm the one that's going to get woken up in the middle of the night if it breaks. Another way of putting that is, the best way to improve the quality of software is to make the engineer who wrote it responsible for it. Okay, so the other cultural ingredient that you need is to assess your risk tolerance. So, companies or organizations can vary within a spectrum of risk aversion, meaning the most important thing is software stability, to perhaps less risk averse, meaning they value moving fast over necessarily avoiding all risks. And then it's important to quantify what that means. So assess like what kind of worst case would be acceptable from a business perspective, and in terms of like percentage of affected users, and in terms of maximum of like affordable downtime. If you can quantify those numbers, then you can kind of identify parameters within the process. So, what, like in the real world, what would this methodology be suitable for? This sort of strategy. So if you're introducing a new feature, this is an ideal candidate. Users aren't conditioned to expect anything of this new feature, and therefore they're not like it's an easy thing to add. You can also add it behind a feature flag, as I described, so that makes it pretty convenient. Things like incremental changes. So if I'm taking my software from state A to state B, I've broken it up into a spectrum of smaller changes. That can be a suitable use case as well. In this case, I've already de-risked it by making the software change incremental, and each of those smaller incremental changes you could use this strategy with. Finally, something like a new service. So I've written a new service, and it's going to be eventually user-facing. At first, I could just have it take all of its normal inputs, but not produce any outputs. or I could make it interact with the rest of the components within my infrastructure, but just like instead of sending any outputs, it would just log them or something along those lines. So this is another pretty simple case where testing in production could work. What's more difficult? Well, mobile apps. Mobile apps are really difficult because there's no rollback, and in general, the mobile release cycle is quite different than something like a web app. If I'm a bank, I probably don't want to do this with my ATMs, and that's because on the spectrum, I'm probably way more risk averse. I never want a bad user experience with my ATM software. And finally, with something like a rocket, generally not a good idea either. Okay, so how do you know if this is working? How do you know if this is accomplishing what you expected it to? Generally, what you'd want to see is a shorter development cycle. And if you can measure it, you should hope, hopefully that metric will improve. You should see more deploys, more frequent deploys. So measure everything. This is a dashboard that we actually have internally where we're calculating for 3 services the number of deploys by day. So actually, to illustrate this topic with a real-life example, I'd like to go into a short tangent, and I call this a tale of 2 services. So this is what actually motivated me to give this talk. So do you remember the quote that I mentioned at the beginning of the talk about people making 2 big mistakes whether or not they take risks? So in the first service that we wrote at PagerDuty, this was in 2014, and it was a back-end service. It was part of our notification pipeline. It's a really high priority project at the time, but of course there's always other high priority projects going on within the company at the time. And so we had to deal with contention headaches. Our development cycle took a long time, in part due to contention, in part due to rigorous kind of like expectations for load testing. So we didn't really adopt any of the techniques that I described, and we basically built the service fully before kind of exposing it to any production traffic, and specifically we went through a long load test cycle. Now, did we make 2 big mistakes? Sure. I mean, as much as load testing can help, there's still things that you can only discover in production, and we did. And the penalty, of course, that we paid is that we wasted a lot of time. So the second service in this tale of 2 services is one that we wrote this year in 2016. Granted, it was a little simpler of a service. It was something that consumed from a data store and published to Kafka. We took a different approach in this case, and we decided right from the start that our goal was to get it into production as quickly as possible. And the kind of approach that I described with a new service is the approach that we took here. We had it receiving inputs from other services, but not actually producing anything, so not actually affecting any outputs. It was containerized, and that made things slightly easier as well. And there's, someone on the team had actually said the phrase, "Prod is the best load test anyway," and that was from a Slack chat. So did we make 2 big mistakes? Yes, we still made 2 big mistakes. So I guess in this case, we proved the quote correct. But the advantage, of course, and what I'm trying to get at is we saved time, and we had it in production within 2 weeks. So bringing it together, what have I covered today? So we talked today about conventional approaches to testing. We talked about the strategy of testing in production. We talked about how, if you want to use that strategy, you should really focus on reducing risk and strategies for doing that. And then I talked about what this looks like in the real world. So lastly, I'd like to go on one more tangent, and this is another tale. This is a tale of a bridge. The bridge in question is the Silver Bridge, and this is a bridge that spanned the Ohio River. It was built in 1928, and it collapsed in 1967. So this bridge actually collapsed due to weight. One of the components in the bridge, a load-bearing component, failed, and it failed because of the amount of weight that was on it in 1967. It was rush hour, and cars were presumably bumper to bumper. The testing or the specs that the bridge had been built for in 1928 assumed car weight, assumed that cars had a particular mass. Of course, cars were much heavier in 1967. So in a sense, you can say that this was a load testing failure. The historian Henry Petrosky had the following quote: "The legacy of the Silver Bridge should be to remind engineers to proceed always with the utmost caution, ever mindful of the possible existence of unknown unknowns and the possible consequences of even the smallest design decision." Now, in light of, I guess, talking about software and strategies that you can use to mitigate risk in software, I would argue that this is true for bridges, but not necessarily true for software. So if you look at software versus bridges, you can see that the deployments of the two things are quite different. We know that rollbacks are very difficult with bridges, but quite easy with software. We know that a bad deploy, the bridge, can be catastrophic. We know that with software, if you have the right systems in place, it can be manageable. And we know that our approach with bridges should be to never fail. You never want to have a bridge fail. With software, you want to make sure that if you fail, you can roll back quickly, and that you minimize the amount of the blast radius. So in light of that, I'd just like to say that the risk-averse approach that we might take with a bridge would be suitable with a bridge, but not necessarily suitable with software. And thank you. All right, any questions? Yeah, so we do rollbacks all the time. It's actually, I don't think we see it as a sign of failure. I don't have a graph for that, sorry. Maybe we should have a metric. Oh, yeah. So one of the things I mentioned was feature flags. So if we did rollbacks, it'd be us internally that are most likely seeing the error. It's a good question, but in general, we have the layer of all those layers that I mentioned of strategies to prevent, obviously there are cases where something slips through and affects our users, but generally this idea of using feature flags for a lot of new software changes prevents external users from seeing it. It's generally internal users that suffer from it. It's pretty quick. I'd say under 5 minutes in general. We have in general our SLA with customers. I forget the number that we provide, but we basically we go into a full panic mode if things are down for more than 5 minutes, or more than a couple minutes actually. We have a process that I didn't really talk about for resolving major incidents, and that kicks off after a few minutes of our service being unavailable. So we take those very seriously. Maybe I should have emphasized that, but I'm actually someone that I play a role of incident commander at PagerDuty, so that's one of the roles that I have at the company. And what that means is if our service is down for a few minutes, I'm getting paged and I'm organizing a conference call, and I'm pulling in technical experts on all the different components, and we're talking about how to quickly get back up. So we take downtime for our customers very seriously. I didn't want to give that impression. Okay. Any other questions?